And so we're going to work on our lesson 7.6 and share whiteboard. So we're getting ready for looking at other Pythagorean theorem proofs tomorrow. And so for today, we want to use the idea of forming three similar right triangles when we start with one right triangle. And we use the hypotenuse as the base to do that. Okay, so let's take a look. Whoops. And so what we've done is we've drawn a altitude. So we flip it over on its base and we draw this altitude. And what we're going to find is that we have three similar right triangles, and you can kind of tell that it has to work this way, right? So if I have a right triangle and the big triangle, so the small triangle and the big triangle both have right triangles, but they share an angle. That means they have 2 out of 3 angles equal. Okay. And so you can kind of see how you'd have to flip it over, but that you'd have to line up the right angles and line up the hypotenuse. You'd have to do a reflection and a rotation. And the same is true for this one. Okay, so that you say, okay, well, C is a right angle, D here is a right angle, the angle right here, and they share the angles A, so the other angle. It has to be equal, they have all angles similar. So let's look at the relationships. So in the big triangle, we have A, B, and C as the sides. Okay, so that's the small, medium, and large sides. And for the medium triangle, okay, so the medium triangle, that includes D and starts over here in the corner. So we're gonna call part Y. So this length is Y. So that's the that's going to be the medium leg. So the medium leg Y, and the hypotenuse of the medium triangle is B. Okay, and we're not going to name CD. We're not going to use that in this proof. And similarly for the small triangle, we're going to X. So part X is the smallest leg, and A, side A, is the hypotenuse of the small triangle. Okay, so for the big triangle, what we can say is that B is to C, so the medium side to the big side in the big triangle is like Y is to B. So what you're trying to get is you're trying to get B on top and B on the bottom. So we're looking for a relationship like that. And so we say, okay, well, that means that B squared equals C times Y. In other words, so in looking at the medium triangle, we say that this side, B, is to the whole hypotenuse as the medium side here is to B. Okay, so we get that relationship. And we say, okay, so B squared equals equals C times Y. So Y is just a part of C, this part of C. And we can do the same thing. And we can do the same thing for the small triangle. So for the small triangle, we also get that relationship. And in this case, we say the small leg of the big triangle, A, to the hypotenuse of A is like X. So the smallest leg to A. And we get, again, what we're looking for is this A on top, A on the bottom. So when we cross multiply, we get A times A equals C times X. And so when we add these two together, so when we add these two together, we have B squared equals C times Y, and A squared equals C times X. And then the insight that you have to have is that you can use distributive properties. So we have C times these two things, C times Y and C times X, when we add the equations together, but that is the same as saying X plus Y, which still doesn't get us there until we look at X plus Y and say, well, what is X plus Y? Well, X plus Y is that division that we've made in C. So it's really x plus y is just the two parts of c because of the altitude that's constructed. And so you say, oh, well, look, now we've got a squared plus b squared equals c squared. So it's an interesting proof. So there's our x plus y. Because usually you actually build squares and do things like that and compare them. And here we're able to do it just with similar triangles. Okay, so the real thing, though, that'll be new to you perhaps, or was something I haven't worked on very much, is the idea of the geometric mean. And the geometric mean is something like this. So if you have two numbers multiplied together, the geometric mean is the square root. Is the square root of 2 times 18 equals 6. So the geometric mean of 2 times 18 is 6, the square root of 36. And so if we compare that to the arithmetic mean, we think about how that works is we add, right? So we would do, say, 2 plus 18, and then we'd divide by 2. And for this one, we're doing 2 times 18, and then we're taking the square root. So we multiply, and we take the square root. So it's an interesting difference between the two. And so we're going to use a similar kind of argument, which is, so in the first of the theorems, it's going to say that, well, so if we read this, it says, if we take that altitude drawn down, okay, the length of the altitude is a geometric mean between these two segments. Well, that's one that isn't so bad to do. So it's saying that for the small triangle, the small leg to the medium leg is like in, oops, keep doing that. So it's kind of similar to what we've had in the other one. And so let's see what we can write down and see if we can get that to come out. So we'll call this guy H maybe. So for the small triangle, we have X is to H, as we have for the medium triangle, I guess, as H is to Y. All right, and so for the small triangle, we have the short leg to the medium, and then for the medium triangle, H is our short leg, so the medium leg is Y. And so if we cross multiply, we get X times Y equals H squared. And so that works out. And so then the challenge for you is, can you do the second one? Okay. And I'm just working on it myself here, which is altitude is drawn. And what they want to do is they want to show, at least what I read it to say, is that each leg of the right triangle, okay, so for example, this leg in purple is the geometric mean between the length of the hypotenuse and the length of the hypotenuse and the length of the segment on the hypotenuse adjacent to the leg. So to me, I'm wondering if it's if it's these, right? So part X to part A. So we'll move this out of the way. And see if we can get this relationship to hold. It's in the length of the hypotenuse and the length of the segment on the hypotenuse adjacent to the leg. So here's the leg. This is the segment on the hypotenuse. So it looks like it would be, you're trying to show that X, relationship between X to X plus Y, or X times X plus Y equals A squared. And so what we'd like to get that to happen, right, is something like this, so that A, so if we could get this, A to C is equal to X to A. So that would do it, right? So if we could get that to be true, can we get this to be true? Okay. So let's just see what that is. So that would be, so we might have to do something else in between. So you say, well, let's give this a try. So we're going to say, so this is in the, so the big triangle, we're saying the short leg to the hypotenuse. What should that be like? So short leg to the hypotenuse would be like A to C. And then we say, well, that is like in the small triangle, that is exactly like X to A. The short leg is X, and the hypotenuse is A. Okay, so you can see that's true, and you want to try and do that in the same one. Okay, so let's talk about the major system. So we want to look at the major system, and we want to think about this because we want to work a little bit on the digits of pi. And so we're going to say if we have a T or a D or a TH, and you can think of this as a single downstroke for the T. 2, and so if you had the word toe, that would be a way to represent 1. If you had 2, you can think of an N as being 2 downstrokes, so N. And 3 is going to be M, 3 downstrokes. Okay. So for example, knee might be a way to represent 2, and for an M, what would be a good M? Can't think of a good one right now. So we can think of maybe man. So if you had man, that would be a 32, a man. 4, you think of R, because FOUR helps you to remember that. And so, so if you had, for example, a tear, like a teardrop, that would be a 1, 4 for 14. For 5, you can think of your fingers. You have 5 fingers, and you can hold them like that. Or you can think of the L of the Roman 50. Okay, so next, think of 6, 7, 8, 9, and 0. So the 6 is like a ch or a sh or a zh. And so the hard part is that some of the G's, so this would be that G soft. Okay, and so we'll think of a word in a second. So let's think of how you do garage after we do 7. Okay, so let's say you had cage. Okay, so here's a guy in a cage. So he's in a cage, right? So the G in that is soft, the cage. Okay, and so if you had a word like nudge, that would be a 26. Okay. But then let's suppose that you have a K. Well, a G can be a hard G. So garage is actually a 7, a 4 for the R, and a 6, 746 garage. And the other thing is, if you have 2 letters that are like a CK or something, let's say that you have tack. So it just you go by the sound. So there's one sound. So tack would be a 1, 7. So 8 is a pair of sounds, f, v. Okay. So let's say you had fan. You had a fan. So a fan would be an 82. You notice how f and v go together. So when you say them, f, v, you can see they're related in where you articulate the sounds. And then whether you're using your vocal cords or not, it's a difference between them. Okay, so if you think of a 9 as a backwards P, it helps you remember that P and B are 9. So if you had a bat, like a bat flying around through the air, getting ready to bring you rabies, there's that bat swooping around eating so a bat would be a 91. And finally, S or Z. So maybe the Z in 0 helps you remember that that's an O. Okay, so if you have instead of, so let's say you have toes. So toes would be a 1, 0. And why are we using those? So let's memorize the first digits of pi. Okay, so let's just start with my turtle poncho will my love. Just start with that. My turtle poncho will my love. And let's just start with that. So we say my is a 3, turtle 1, tur 4, turtle 1, 5, poncho 9, n 2, 6. Will, so the will doesn't make anything, so it's just a 5, 3, 5, the 8. Okay. So that gets us, my turtle poncho will my love. And then the sentence continues, pick up my new mover Ginger. Pick up my new mover Ginger. My turtle poncho will my love pick up my new mover Ginger. Okay, so love, and then we have the 8 there. So P, our 9 there. 7, 9, my 3, n, 2, these, nothing happens here. 3, 8, 4, j, is a, have to remember that. Ginger, so this is both 6s. 2, 6, ginger, 4. So how many digits do you get out of this? Well, let's just count them up. So after the whole number component, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you see 5, 10, 15, 20. So you get quite a bit way just with one sentence. So my turtle poncho will, my love, pick up my new mover, Ginger.